today's lesson, we are graphing linear equations from slope-intercept form. As usual, we have a video guide to go along with this lesson, so if you have not printed that off, go ahead and pause the video, print that, and come back. Now, in previous lessons, we've talked about finding slope in the y-intercept from slope-intercept form. So today, we're going to use that information to actually graph it on a coordinate plane. One thing I want to talk about is what a linear equation actually is. You'll notice in the word linear, you will see the word line. So a linear equation is an equation where the solutions create a line on a graph like this. Okay, so that's what we'll be working with today. And also remember, slope-intercept form is y equals mx plus b. Okay, where m stands for the slope and b stands for the y-intercept. And y-intercept is where it crosses the y-axis. That's our vertical axis. All right, so we're going to start by taking a look at number 1. Our equation is y equals negative 3 halves x plus 1. Now, the first thing we're going to identify is the slope and the y-intercept. So the slope for this equation is going to be negative 3 over 2. The y-intercept, which is always that last number, the slope is in front of x, the y-intercept is at the end. It's a plus 1, so that makes it a positive 1. Now, to graph this, you always start with the y-intercept. Okay, start here first. The y-intercept gives us our starting point on the y-axis over here. So if it's a positive 1, what we do is we go over to the y-axis and we go up to positive 1. That's where our first point belongs. So a nice point right there. Now, to find other solutions, other answers for this equation on the graph, we're going to use our slope, okay? So our slope here is negative 3 over positive 2. Now remember, slope is always rise over run. So if our rise is negative 3, that means we need to go down 3, because rise is up and down. Negative 3 means down. So we would go down 1, 2, 3 places. I'm going to put a little mark. Don't actually put a point there, okay? Because we have to do the run as well. So there's 2 directions that we have to go. We have to do the up and down. We also have to do the left or right, okay? So we went down 3. Now this is a positive 2 here. Go ahead and put a positive sign. So my run is a positive 2. Now run is left or right. Remember, left is always negative, right is positive. So if this is a positive 2, that means I would count to the right 1, 2 places of my point, okay? So that would be the next point on this graph. Now, at this point, we can actually go and do our slope again, okay? So I'm going to start at this last point that I made, and I'm going to go ahead and do negative 3, positive 2 again. So I'm going to go ahead and go down 3, to the right 2, and put another point. You can keep going. You could go on forever and ever. However, our graph stops. We don't really have room to put another one, so we're going to stop, okay? If we had room, we could keep going. If we don't have room, we'll just stop, okay? So, after that, I always like to go as many as I can on the graph because all of these points represent solutions to this equation, okay? They're all answers to this equation. So the more answers I can show, the better. So I also like to go in the opposite direction. To do the opposite, instead of counting down 3 places to the right 2, the opposite would be to go up 3 places, left 2. Now here's the reason why we can do this. Let's look at it on the graph. If I start here at my y-intercept and I do positive 3 for the rise, or up 3, and then I go to the left 2 because that's a negative 2, you will notice it's still along the same line. See how they're making a line right here? Linear equations make a line on the graph. So as long as it's still along that same line, it's still an answer. Also, if you'll notice, if I started at this point, I could go down 3, right 2, and still get back to my y-intercept, which is this exact directions that we started with, okay? So by doing the reverse, that just allows us to go on the other side of the graph. Shows more answers, all right? Now what we do, our last step, is we're going to connect all of these points with a line. So I'm going to try to make it as straight as possible. If you want to, you can always use a ruler for this. But they're connected by a straight line. What that means is even these points between, even these places in between the points, these are still answers. These are still solutions. They're just decimals or fractions, and I can't write them all, right? I don't know exactly what this fraction is, all right? I could try plugging in like 1/2, -1/2 for x, and finding that solution, but graphing it just gives us a visual of that. So even these points in between the points that we've created, the nice points on the graph, all of these points on this line are solutions, okay? We just don't show all of them, all right? Now I put arrows at the end because technically this line goes on forever. If I tried to make a graph of this line, I'd run out of paper. There's no way you can make a graph to show all of the answers for this equation. So we just do the ones between like 6 and -6, okay? We kind of box it off because we don't have room to make them that big. But it gives us a visual representation of what the answers are doing. And if we think about it, we learned before in previous lessons that negative slopes always go downhill, which is exactly what's happening here. Our line is going downhill. So that's one way to kind of check and make sure that you're doing it all right. If this had been going uphill, I'd know, oops, I did my graph wrong, okay? So you're always creating lines, and you should be able to tell by the slope whether it's going downhill or uphill. So that's number 1. Let's take a look at number 2. For number 2, our equation is y equals 2x. The first thing we need to do is figure out the slope and the y-intercept. My slope is always the number in front of x, and so in this case, my slope is going to be 2. But we always want rise over run for the slope. So I need a fraction. Well, whole numbers are fractions, just the denominator's not really written. So if we make this over 1, I now have my rise and my run. So anytime you're given a slope that doesn't have a denominator, always, always, always put +1 in the denominator. It doesn't matter if the numerator is positive or negative. That denominator is always a +1, okay? So 2 over 1, that's my fraction. And then my y-intercept, you'll notice there's nothing here, okay? So I'm missing the last number. So my y-intercept is going to be 0. The only number that represents nothing is 0, so I just put 0. And now I can graph it. Always start with the y-intercept, right? That comes first. So to graph the y-intercept, I go to the y-axis and I go to 0. Well, 0 is located right in the middle. So that's where my first point goes. After that, I use my slope of 2 over 1. So they're both positive. So that means my rise is going to be a +2, so I go up 2. And my run is a +1, so I go to the right 1, and I put a point. Now, I have room on my graph, so I'm going to continue this. I'm going to go up 2 to the right 1. Up 2 to the right 1. And then I run out of room this direction. Let's try doing the opposite. So, if my order was up 2, right 1, the opposite would be down 2, left 1. So let's do that. Go down 2 to the left 1. And look, it's still along my same line. So I do it again. Down 2, left 1. Now, you'll notice that when I did the opposite, I do the opposite of both numbers. So instead of +2, I did -2. Instead of +1, I did -1. Okay? And then, just like before, we connect our points with a line. Remember, all of these points along the line are solutions. They are answers to this graph. Okay? All of these are answers. So, that is a visual representation of this equation. You will notice that this is a positive slope and my slope is going uphill. So it's also positive. So again, I did this correctly, but it's a good way to check and make sure that you have your graph written down. For number 3, our equation is y equals 7/3 x plus 5. First thing is to identify the slope and the y-intercept. My slope is in front of x, 7/3. My y-intercept is the last number, so that's positive 5. Graph your y-intercept first. So my y-intercept is a positive 5, so I need to go up 1, 2, 3, 4, 5 places. From there, I'm going to use my slope. It's a positive 7/3. So remember, that's the rise and the run. So my rise is a positive 7. My run is a positive 3. Well, if I start at 5 and try to do a run of positive 7, I run out of room. Okay, I don't have enough room to do a positive 7 for the rise. However, let's look at the opposite. So I should go up 7 to the right 3, but the opposite would be down 7 to the left 3. And that I do have room for. So let's just go ahead and use the opposite. I'm going to count down 7 to the left 3 and put my point. From there, I can't go down 7 again. I'm again run out of room. So I'll go ahead and connect my points with a line. And you'll notice my slope was a positive slope here. And look, mine's going uphill. It's a positive slope as well. So I graphed this correctly. So using the opposite, remember, negative over negative is still a positive. So these mean the same thing. It just helps us with direction. Positive 7 over positive 3 would be up and to the right, but negative over negative allows me to go down and to the left. For problem number 4, our equation is y equals negative 4. This one's a little tricky, okay? We're missing the x. So I can't just say that the slope is negative 4 because that's not the number in front of x. There is no x. So there's actually no slope that we can write down. What we're going to do is we're going to go to the graph and we're going to go to where y equals negative 4. So that means go down 4 places, put a point. Now, most people want to stop there and say that that's the only place where y is negative 4. However, you will notice that if I go over here and I write down this point, x coordinate is negative 2, the y coordinate is negative 4. This coordinate has a y coordinate, a y of negative 4. So y still equals negative 4 here. X equals 2, but you'll notice x is not in my equation. So x is kind of whatever we want it to be. We can pick any number we want for x. As long as y is negative 4, that's all that matters. So I could go all the way over here and do negative 5, negative 4. The y coordinate is still negative 4. That's all that matters. The x is now negative 5, but it can be whatever I choose it to be. It's not in the equation. So we could go over to the right side, and we would have this point as 6, negative 4. Again, x doesn't matter as long as y is negative 4, it's a solution. So you'll notice that these points make a straight line, straight horizontal line. This is one of those special graphs. We talked about the special slopes. There were 4 types. Positive, negative, which is what we've been doing for problems 1 through 3. But there's also the 0 slope and the undefined. Now remember, the 0 slope is always horizontal, okay? So this has the 0 slope. 0, okay? The slope is 0 for this one. It's just staying constant, going straight across, left to right. All right, so anytime you have y by itself, the slope is going to be 0. X equals 1. So we'll go to the x-axis this time, and we'll go to 1. But if we think this through, just like with the y, x, that's not the only place where x is 1. If I go up to this point here, the x coordinate is 1, the y coordinate is 4. But this time, I don't care what y is. It's not in my equation, so y can be whatever I want it to be. But x has to be 1. And in that point, the coordinate for x is 1. I could go all the way down here, and this point is 1, negative 3. The x coordinate is still 1. The y is negative 3, but that doesn't matter. So this kind of line is actually going straight up and down, a straight vertical line. As straight as you can make it. There we go. So this would have the undefined slope. All right, so two special types of slope, the zero and the undefined, two special types of equations. This equation is missing the y. Anytime that happens when you only have x, you will have the undefined slope, always. If x is the only letter that's in your equation, it's going to be the undefined slope. And same thing goes for y, as far as if all you have is y in the equation, it's going to be the zero slope, always. Okay? It doesn't matter what number it's equal to, as long as it's only x equals a number, it's undefined. If it's y equals a number, it's zero. At this time, go ahead and try number 6 on your own, and then come back and check your work. Let's take a look at problem number 6. We were given the equation y equals 4x minus 1. The slope is 4 over 1. Always make it into a fraction. The opposite of that would be negative 4 over negative 1. Okay, both of these are the same slope. The y-intercept is always the last number, so that's negative 1. So to graph it, I went down 1. And then I used my first slope, 4 over 1. I went up 4 to the right 1. And then I did the opposite. I went down 4 to the left 1. I can check my slope. It is going uphill, so it should be positive, which it is. And that's the end of our lesson on graphing linear equations from slope-intercept form.